All right, welcome to Symmetry and Dilation. The learner will determine different types of symmetry and you will use scale factor to dilate an image. All right, so let's get started with this one. This one's not too bad. These are hopefully fairly easy. I'm not going to spend too much time on the symmetry part, but I will try to spend a little bit more time on dilation. Both of these are fairly easy subjects. Okay, so symmetry. There is types of line symmetry. There are three types of symmetry. We have line symmetry. A figure that has line symmetry is the figure can be mapped onto itself by reflection of a line. So like when you did the quadratic formula and you did this little parabolas and you were finding the line of symmetry, that for algebra 1, that was line symmetry. But geometry, we can always do a little bit more. We can have point symmetry. A figure has point symmetry if the figure is mapped onto itself by rotating the figure about 180 degrees from a center point. So keep in mind, this one is 180 degrees, and it would still be the same. So if you did it like 180, you would still look the same. Whereas rotational symmetry, figure has rotational symmetry if the figure is mapped onto itself by rotating the figure less than 360 degrees. So they're not telling you how much it needs to be rotated, just that as long as it's less than 360, and then that would look the same, then it has rotational symmetry. So let's look at some of these types, and I'll show you. And this is just going to be kind of a multiple choice type of thing. Okay, so the question then becomes, first off, I guess the easy one is, can you get like line symmetry? So in other words, could I draw a line? That was poorly done. But where if I folded it in half, it would be the same. And yeah, it doesn't matter where the line goes because I can do it like this, or I could do it like this. I could even do diagonally. And as long as it would fold over and be the same, at least one line, that makes it line symmetry, okay? So I could easily do this one like across here. I could easily see that that would flip over onto itself. So yes, this is line symmetry. Now, the point symmetry and rotational symmetry, okay, point symmetry, if you rotate it 180 degrees. So basically, does it look like there's an equal top half, bottom half type of thing? Like if you rotate it completely, would it go the same? So I'm going to try something here real quick and see if this works. Okay, so there's me trying to rotate it 180 and it looks the same. Okay, now if I try to rotate it less than 180 or anything different, that would make it rotational. Okay, so this every single time you can see it kind of gets back. Now I'm back to the original. So this should be point symmetry and rotational. Obviously it can't be none because, well, if it's one of those, it's like that. Okay, so if I look at number two, I've got, like, I can make a line. Ugh, good grief, I'm horrible at this. And that would flip over, so line symmetry. Obviously it's not going to be rotational symmetry. I'm sorry, point symmetry, because I can, if I flip this 180, let me do this real quick. If I flip it 180, I get something like that, which I don't want, but I could keep flipping, and like after, say, so many degrees or so, it gets pretty much the same thing, but it's because my trace outs were horrible, so you kind of get the idea. So this one is not point symmetry, because point is only 180 degrees, but it is rotational symmetry. Okay, this one, there is no line symmetry, because if you flip this over, that's going to be over here, so that won't work. Flip this over here, this point would be over here, so it would not work for line symmetry. Visualize, because I'm not going to draw this one out, but this one does have point and rotational symmetry, because if I flip this one 180 degrees, that point would be over here. So, and then if it's point symmetry, it should probably be rotational symmetry by definition. All right. Number 4, that's an example of none. So you kind of get the idea. And number 5, you have line symmetry because you can cut a line through here and you get the exact same half if you draw the line really well. But you don't have point symmetry because this point would end up down here if I rotated 180 degrees. So, but you do have rotational symmetry because I can go from, like, say, this point to this point and look the same. Kind of like that. most of this is how well do you visualize, okay, and see what you figure out. What about number 6? What do you think? I won't say a thing yet. Pause. 5, 4, 3, 2, 1. You're right. It should be, whoops, should be point and rotational symmetry. So I'll go ahead and that's really it. That's it for symmetry. That's all I want y'all to be able to do is identify the different types of symmetry. Later on, that might become something more important in another class, but that's really all we're concerned with right now in this one. All right, so let's move on to dilations. Dilations are the enlargement and or reduction of a figure. The scale factor tells you how much you're going to enlarge or reduce, okay? The variable for the scale factor we like to use is k. If k is greater than 1, then we have an enlargement, so it got bigger. And if k is less than 1, we have the dilation is a reduction. Reduction. Okay. All right. So, let's go with bigger figures. Okay, so we can see here is triangles RST with vertices -5, 1, -3, 4. We're going to say scale factor 2. Okay, here's the thing. And I'm going to show you the graphs. But all you got to do here is multiply. So if you multiply this 2 to every coordinate, you would get the answers here. So here, like -10, 2, 2 times -3 and 4 is -6, 8, and 2 times 2, 1 is 4, -2. So what does that look like? So I'll do the original in green, and I'll show you the new one, the image, in red. So like the pre-image will be in green, the image will be in red. Okay, so you can kind of see this recording here, or this image here, and you can see in green is the original image. That is the original, the original picture, diagram, whatever. And again, don't forget that's called the pre-image. And then the red is the actual image, the dilated figure, so the enlarged figure. And you can see those coordinates would just be just like that. So again, all that is just a quick multiply, and you've got your answer, and it should hopefully be fairly simple. So in this one, let's see if you can go ahead and give me the coordinates and go from there. So what you should have gotten is -9, 0, 3, 6, 6, 0, and -6, -6. Okay, so again, fairly easy. And then if you want to see the graph, okay, and you can see how this one worked in for this one for B prime, and you can kind of go from there. You can see again the pre-image was in green, and the dilated enlarged image is in red. So what happens if I have a fraction? Oh no, not fractions. Okay, so fractions again are just multiplying by, well, it's multiplying by a fraction, but again, keep in mind that you're like say multiplying by the top number dividing by the bottom. So if something like this, like if I said 1/2 scale factor, then multiplying everything by 1, the numerator is not going to do anything, and then divide by 2. So like basically 1/2 is dividing by 2, right? So then that should tell me about this new image is going to be -5, 1, -1, 4, 3, 1, and then -1, -2. Okay, so what would that look like? Again, let's do the pre-image in green and then the image in red. Okay, so for this one you can see here how I did that. Notice how it is the much larger image and versus this one. So and this was what would help us develop like the idea about like area, but we don't have the time. We didn't have time to go over that. But like the area of this right here and what's its relation to the area of the preimage and stuff like that. But again, maybe that's something we'll look into. I got a little distracted there, something happened, so I need to just check on that. But let's look at this next one. So we have triangles. Triangle WXY with vertices -4, 8, 10, 0, and -2, -8. So let's reduce that by a scale of 1 over 4. So we're going to just multiply. Again, like I said, you don't necessarily need to graph a lot of times with these, but it helps to see it. So I'm not requiring it. You can just give me the coordinates, but because I know some of y'all are going to have some problems with printing and stuff like that. But go ahead and multiply it out and see what you get. So I'll pause me for a second if you need to, whatever, and we'll go from there. All right, so now let's look at this, and you should have gotten -1, 2, because all I'm doing again is multiplying by 1 and then dividing by 4. If this had been like 3/4, I would have multiplied each number by 3 and then divided by 4. So, I mean, you kind of get the idea there. So all I'm doing there is that. 10 divided by 4 is 2.5. I'll go ahead and do that as a decimal. 0, -2 is -0.5 or -1/2. I'll leave it as a decimal for y'all. I know that's what most of y'all are going to have in calculators. So how would I graph that? Well, let's look at the preimage first. This one I'll let you see how I actually graph it out because of those decimals. Oh no, there's decimals. I don't know what to do. Alright, so -1, 2 would be right there. So that's going to be W prime. Alright, then I got 2.5. So that's halfway between 2 and 3. So right there, 2.50. So there is X prime. -0.5. Oh no, it's between 0 and -1. But I'm going to go down 2. So it'd be right there. So not that hard. Y prime. That's all I'm doing. You know, approximating, getting it close. And there you go. That's it. Alright, so y'all should be able to do this. Like I said, it's fairly easy. Let's see what we want for the assignment. Now, I was about to give you the assignment, and then I realized, hey, there's a problem here that I want to be able to go over. Most of these between number 4 and number 11, they're basically the same thing, although starting at number 7, they do want you to like come up with the coordinates yourself. I mean, they give you the drawing, and you're supposed to come up with the coordinates. So like there, you got to get the coordinates and then multiply and go from there. So, I mean, if y'all have questions on that, feel free to ask. But here, how do I get the scale factor? And this is where I've been saying before, like new over old. Remember when I would tell y'all about that? Okay, so I would pick a coordinate like here. Like let's say D. If you look at D, you got a point of 0,6. I mean, you pick one that's easy, and it really doesn't matter which one you pick, but 0,6. And then you D prime, so I'm going from this one to this one, and that is 0,2. Okay, so if I look at the y coordinates, because the x coordinates are not going to help me at all, and just say new over old. So the new one is this one. Remember, the one with the prime is the new. Okay. 2 over 6, I get 1/3. And there's my scale factor. And that's all I needed to do for that. So if you kind of work it like that, you should be able to do those fairly easy. Okay? Anyways, so what is the assignment? Now I can get to the assignment. Okay, so for the assignment for my CP classes, what I want y'all to do on the symmetry, which is pages 1 and 2, you want to do problems 1 through 20. I think I already did like the first 6 for y'all anyway. So, I mean, you've got quite a few of them, say, taken care of. And then on pages 4 and 5, so you can skip page 3 completely. 1, 2, 3, yeah. And on pages 4 and 5, you can do problems 1 through 12. These should be, this one right here should be symmetry. And this one right here should be dilation. Okay, and then for the pre-AP classes, I want you to do all the problems, kind of go from there, and that should be it. Anyways, guys, as usual, if y'all do have questions, feel free to ask. But thank you so much for your time. Y'all take care, be safe, and be well.